Let's go ahead and start. Apologize for the webcam being over on the side over here. I'm redoing my little space here, and still haven't got my webcam adjusted if I put it on my new monitor. Eyes are getting worse, so I'm making my monitor a lot larger. Okay, we're going to talk about confidence intervals and about claims, hypothesis testing. It's a little bit bigger so you'll be able to see it. Excuse me. Let's just generally talk about confidence intervals. Okay. Age at a college. Well, if we're focusing on average, the mean, maybe I can make the claim that the average age is going to be 20. Now, age is a continuous variable, so the chances that I'm correct are non-existent. I wouldn't put any money on this, maybe a quarter. if you wanted to gamble on this. I always ask somebody in class, so what's the average age of students here at the college? And somebody say 20. And I say, are you willing to put $1,000 on that? And they look like maybe they might be willing to until I indicate to them it can have decimals. So the average age might be close to 20, but it may actually be 20.1. Might be 20.13, 5, 7, 1, 2. You can keep putting decimal places on there. The chances that it's exactly 20 are non-existent. Okay. Well, if it's non-existent, then how can we, work with this then? Well, we have something called a confidence interval. Instead of saying that the average age is 20, we say that the average age is between 18 to 22. Confidence interval is just a range of values. So the confidence interval. Now the smaller part of our interval is our lower bound. The book, I believe, refers to that, or the material anyway, refers to that as the lower limit. And this is the upper bound, or upper limit, according to the book. So if you see them referring to that, that's what they're talking about. Now, we got a value exactly in the middle. And that's called our point estimate. Point estimate is your best guess. So that's your best guess. Now, assuming our lower bound here is 18 and our upper bound is 22, you probably can just look at it and see that your point estimate is going to be the value exactly in the middle, or 20. So your point estimate is going to be equal to 20. There's formulas for that. Your point estimate is going to be your lower bound plus your upper bound divided by 2. This is useful if you can't easily see it. Well, if I put that in there, lower bound is 18 plus upper bound, which is 22, divided by 2. And that gives us 40 divided by 2, or gives us our 20. Now, for different sections, the point estimate will have a different symbol. One of the symbols you see for point estimate is X bar, sample mean. So here, if we're referring to the mean age, which we are, the average age, then our point estimate would be labeled as X bar. So this would be X bar is equal to 20. That's our point estimate. Another one you see in this section is P hat. That's for proportion. So if you see those symbols, that's what that's referring to. Now sometimes, especially when you're dealing with proportion, your interval will be written differently. Now this is 18 to 22. When you're talking about other ways you can write it, you may see it written this way. This is very popular. 18, 22 with parentheses. It might be written as 18 is less than mu is less than 22. Sometimes you may see lines underneath here, means it includes those values. Typically you have less than, since it corresponds with the parentheses here. Because what's probability that it's going to be exactly 18? Non-existent. Might be 18.23572. It'll have decimals, won't it? So that's why a very standard practice is to say, well, it doesn't include the value, because the chances of being exactly 18.22 are non-existent. Okay. Doesn't mean that it doesn't exist, but very low probability. Now, when you're talking about proportion, learn to speak here, you might have this right here. This is popular in polls. 30% plus or minus 2%. So this is the way it's written. And you may be sitting there, well, that doesn't look quite the same as these. What this is saying is you're going to have 30 minus 2 and you'll have 30 plus 2. Well, 30 minus 2 is 28. And 30 plus 2 is 32. So my interval is from 28 to 32%. Okay, well, what does this mean? We've talked about kind of the mechanics of what these numbers are, lower bound, upper bound. We said that this is a range of values, but what we're really indicating is that the true population value is somewhere in this range. So the true population age, for example, mean age, is between 18 and 22. And that's why we got mu here. Remember, mu is your population mean. So we're saying it's somewhere between 18 and 22. Now, if we're talking about proportion, this might be written as 0.28, comma, 0.32 with parentheses on it. Or you could have it in percent form. So if you see it either way, then they basically mean the same item. This is just written as decimal, this is written as percent. If they're talking about proportion, they usually write it in decimal form. If they're saying percent, they're writing it in this form. And what we're saying here is that the true population proportion, which is P, so 28 is less than P is less than 32. So this is our symbol for the population. So the population proportion is between 28 and 32%. Okay. Now 18 and 22. Let's say my college has quite a few non-traditional students. Well, what's the chances it's going to be between 18 and 22? Well, we might say that we're 95% confident that it's in that range. So there's a degree of confidence that goes with a confidence interval. We can say this is our range of values, but how sure are we that it actually contains a true population value, like mu right here, I guess. Now we could change this. I could say 0 to 100, and then all of a sudden my confidence has changed. I'm 100% confident that the true population mean of ages is somewhere between 0 to 100. I'd bet every amount of money I had on that. Am I saying anything? No, I'm not. You know, it's pretty obvious the average age of a student is going to be between 0 to 100. And we're not talking about an individual student, we're talking about all the students taken as a whole, the population. Now I might get very specific. I might say the age is somewhere between 19.1 to 19.3. But then over here I might say that I'm 7% confident of that. Now I'm being very specific. I'm saying, okay, it's really in this range right here, 19.1, 19.3. But I'm not very sure of that. I'm only 7% confident of that. Here, 18.22, I think it's in that range, and I'm 95% confident of it. So what you'll find is that when you increase your confidence over here, it'll make your range increase. Now, if your confidence decreases, then your range decreases. So again, as this decreases, then our range decreases. Magic number to use is if they don't say otherwise, you always go for 95%. A lot of times they'll give you a different one, 99%, 90%, and so forth. But 95% is pretty good. That's an A. Okay, let me clear this off. And we got our age here between 18 and 22. This is going to be our lower bound. This is going to be our upper bound. We said that our point estimate is a value exactly in the middle. For this, for the mean, that'd be x bar. So x bar is going to be equal to 20. And again, that's point estimate is equal to lower bound plus upper bound divided by 2. Let's try it again. There we go. The little divots in my tablet. Now we also have something called a margin of error. Now your margin of error is represented by E. And the margin of error is the difference between your exact middle, the point estimate, and one of the bounds, one of the limits. So your margin of error might be equal to upper bound minus point estimate. And this is just general. This applies no matter what section you're in. Upper bound would be 22 minus our point estimate, x bar, which is 20. So our margin of error is 2. Now another formula you can use for your margin of error is you could have your point estimate minus your lower bound. It'll give you the same value. So our point estimate was 20 minus lower bound, 18. So your margin of error will be 2. Now, that's how you find your margin of error. If you're dealing with proportion and you're given the confidence interval as something looks like this. %, plus or minus 3%. What they're giving you always in this format is they're giving you the point estimate, that's the 10%, plus or minus the margin of error, which is 3%. So if I have it in this form, automatically your point estimate is 10%, and your margin of error will be 3%. So you don't have to use these formulas when it's in this form here. And again, this is very common for sampling. If I'm doing a survey of sampling for politics, sorry. If I'm doing a survey, asking what people think about this candidate or that position, then you'll see this notation. Okay. Now I've come up with a spreadsheet to help you with the problems. We got 3 options. Confidence interval about a population mean sigma is known. Confidence interval about a population mean sigma unknown. And confidence interval about a population proportion. And if you fill in the values, you see this asks you for x, n, and percentage. So let's say I talked to 300 people. So I put 300 in for n there. And 25 of them like some TV show. So I'll put 25 in there. And I'm wanting to find the confidence interval, 95%. So if I put in 0.95, then down here, this will give you your answer. Now, if we were to look at this, this is going through and doing quite a bit formula-wise. So if you're curious about that, you can explore that. You can look at the look at the formulas and see how I do it and so forth. I don't have it locked down or anything. Over here, confidence interval about population mean sigma is known. Well, they tell us the sample mean is 22.1. They tell us population standard deviation is 1.2. My n was 42, and I want a 92%. I put in 0.92. Then now give me my interval right here. And then along the same lines are where sigma is unknown. You use this. So mean sigma is known, mean sigma is unknown, and population proportion. Let me give you a little flow chart on how to use that. Okay, so we got a asking to find a confidence interval. Now it's confidence interval about a mean. Now that's sometimes hard to identify, or it could be about proportion. Now remember, another word for proportion is percentage. That's a little easier to identify. And then you'll either have sigma's known, or you'll have sigma's not known. Like that. So you're reading it. They say find a confidence interval for the mean age of college students at a college. Well, the mean, confidence interval mean, we're sitting right here. And then you have to read to see whether sigma is given or not. Sigma is our population standard deviation. So that's our population standard deviation. Then you, whichever way it goes, then you pick the appropriate part of the spreadsheet. And for proportion, if it says proportion, find a 90% confidence interval for the true proportion of students who believe in UFOs. Then since it's referring to proportion, that's what you use here. Okay. Now let's talk about sigma. Sometimes I have people ask, well, how do you identify sigma? That's hard. What is sigma? Because that's the whole driver in which one you use. If you identify sigma wrong, you use the wrong part of the spreadsheet. Well, one way to identify that sigma is given is it'll say sigma is equal to something. So I'll give it to you directly. If you see the wording, population standard deviation. So if it gives you population standard deviation, if it gives you a standard deviation, so it tells you a standard deviation is something, without referring to a sample. Those would all be sigma. Let's talk about examples. I walk into the room. I say, okay, the ages of students at this college are 20 with a standard deviation of 2.5. Notice I did not refer to a sample at all, did I? I didn't say out of a sample of 20 students this was true. Well, I just came in and said the mean was this and standard deviation was this. Since I did not refer to a sample, that would be sigma. On the other hand, if I walk in a room and I say, okay, I talked with 25 students last week, and I found that the average age is 20 with a standard deviation of 3.1. Since I'm referring to the sample, then that's our sample standard deviation, which is S. That's not sigma. So sigma is not known in that particular example. So again, close reading of it will help you determine whether it's population standard deviation or sample standard deviation. And that's the first part here, these confidence intervals. Now the second part talks about the claim. So let's talk about that. Clear this off. And let me grab a drink real quick. Okay. My claim is more than 20%. 20% of people are watching Breaking Bad on Sundays. I was watching it before I got online here, so that's why I use that example. We're going to have an H0 and H1. Now this H0 here is our null hypothesis. And this H1, some books refer to as HA, that's our alternate hypothesis. Forgive my writing. Okay, so that's null hypothesis and alternate hypothesis. Now, we're talking about percent here, so it's going to be P. You're either going to have P or mu. Remember, mu is our U with an extra line. That's mu. More than. I have to think what symbol that is. Well, more than is greater than. Now I'm going to put the greater than here on H1. And although books follow this with different convention, what I want you to do, because I think it makes life easier, is this is always equals no matter what. Now the symbols you can put on H1. You can put a less than, greater than, or not equal to on it. The symbols you can put on H0 are always in equals. So when I came up with this greater than up here, there was only one place I could put it. I had to put it down H1. Now you're going to, in these problems, identify whether your claim matches H0 or H1. And it's based upon your symbol. Greater than, greater than. Here our claim matches H1. Okay. Our claim, the mean age is 22. Well, coming up with our null hypothesis and our alternate hypothesis. The mean is mu, always. Now, if I think what symbol this represents, mean age is, that represents equals. Remember, the only place we could put an equals is on H0. Now, we tend to think of these as opposites of each other. Sometimes they get kind of tricky. The opposite of equals is not equals. So that would be our setup. Now our symbol. Here's an equals, here's an equals. So our claim matches H0. Now you might say, well, they're opposites. What do you mean about that? This says greater than here, and the opposite of greater than is not an equals. The opposite of greater than is less than or equal to. And some books actually put less than or equal to here. And if you watch the videos I created, I actually do that, showing that. But that's not the way we're going to work it. The standard that everybody's going to is they always put an equals and H0 no matter what. For better or worse. Okay, let's say my claim is that the mean pages in a book, for example, is less than 100. Come up with our H0 and H1. Well, mean pages is less than 100. And of course, these are mu because it's mean. The only place we can put a less than is on H1. Now again, you think of these as opposites each other. If this is a less than, this would be an equals, although that's not exactly true, being opposites. Now our claim is less than, that's the less than symbol right there. That matches this right here, so our claim matches H1. Okay. Let's say our claim is at most the age, let's say average age, at most 30. At most. You have to think what that means. I always tell people in class, I say, if this wording throws you, think of if you're trying to give somebody money, and you're going to give them at most $30. Well, you may give them $20, may give them $25, $27, $29. You'll give them perhaps $30, but that's at most $30, so you won't give them over $30. So at most, that implies less than or equal to. Okay, now you're sitting there thinking, okay, well yeah, but where's that go? You didn't even list that. There's no less than or equal to over here. Well, let's just think about less than or equal to. The opposite of less than or equal to is greater than. Where does greater than go? Well, greater than goes always on H1. So this would be greater than 30. And the only symbol we can put on H0 is an equals. And if you think about it, less than or equal to does have an equals here. So the only thing we're writing down there is the equals portion. Now that throws people sometimes. Because they think, okay, this is equal, this is always not equal. And that's not true, as you can see with this example. Now you might look at this and say, well, it doesn't matter, doesn't match either one now. This is a less than or equal to, and this is an equals. But again, we go off the equals part, so this one right here would match H0. I think it was last semester I gave this on a claims on a test. I had so many people miss it, I could not believe it. Age is at least 40. I had more people put less than on this, at least. Say I was talking about money. I'm at least going to give you $40. Well, it means that the very minimum amount I'll give you is 40. I could give you 50, 60, 70, 80, but I'm at least going to give you 40. So the at least implies greater than or equal to. Okay, well, that's confusing. Let's come over here. We got greater than or equal to. The opposite of greater than or equal to is a less than, which means a mu would be, forget color. Let me change it black. This would be less than 40. And again, the only symbol you can put on H0 is an equals always. And our claim has the equals part on it, matches the equals on the H0. Now that's the first part of our process, is you write down your claim, and then you write down a null, and the alternate hypothesis goes along with it. This is how we're going to do our claims with the p-value approach. And a p-value approach is a geometric approach. The p-value represents area in your picture. And if your area, the p-value area, falls within a tail, that's a reject region for H0. If it's greater than the area in the tail, then it goes into the accept region. Okay, now I'm going to talk more about that because that's a little bit confusing. Write down a shortened version of the claim. Come up with a null and alternate hypothesis. We've already seen lots of examples of this. Notice that H0 always has the equals part on it. See if your claim matches H0 or H1. Again, we've been doing that. Then we'll find a p-value. And if your p-value is less than alpha, we'll reject H0. If your p-value is greater than alpha, you accept H0. And then determine the claim based on step 3. Okay. Let me give you an example of that. Let me clear this off. Okay, so my claim is that the age of students is more than 20.2. Okay, I go on, I do a study. I talk to 25 students, for example, and I find that the average age is 20.3, and I find my sample standard deviation is 5.1. And they give something called alpha. They tell us alpha is equal to 5%. That's a Greek symbol. I don't make it very well, but that's alpha. Okay, so this is all the information we're given. Now, if you look at this, 20.3 for x bar, that's obviously greater than 20.2. So you might think, okay, it's valid. That claim is valid. Well, what we're talking about is significance level. Is it significantly greater than 20.2? For an example, you have two people dating, and the guy's 3 years older than the woman. Maybe he's 33 and she's 30. Is that a significant age difference? Is his age significantly greater? Well, we'd say in that case, no, probably not a significant difference. Now, in other cases, you go down to a 14-year-old dating a 17-year-old. Well, that's at that age, 17 is significantly greater than the girl. So significance is kind of a in reality, it's kind of an iffy idea. But that's what we're talking about here. We're not talking about whether it's greater than 20.2. We obviously can see it is. We're asking, is it significantly greater than? And this level of significance helps determine, well, what do we consider as a really significant? So as you adjust this, then that'll change your claim result. Now, 5% is a kind of standard one. Remember how I said in confidence intervals, we said 95% was a magic number? Well, the 5% is the amount that's given in tails. 95% was the amount that's in the main body, if we were looking at a picture of it. So they're kind of the same concept, but you never are given this. You always give an alpha in these. So alpha is 5%. Okay, step 1, write down a shortened version of the claim. Usually you want to keep this as short as possible. So mean is more than, I'll go ahead and actually even put the symbol here, 20.2. If you get too wordy on your claim, it's going to mess up this process. Well, mean is mu. Now there's only, and then the next step 2 is come up with a null and alternate hypothesis. Greater than, the only place we can put that on is H1. So it'll be greater than 20.2, and then this will be equals. That's always equals. Step 3, see if your claim matches H0 or H1, and that's based upon your symbols. This is a greater than, and here's a greater than. So our claim matches H1. Find your p-value. I'm going to give you a flowchart on this here in a minute, but specifically, we're dealing with the mean, even though they didn't say average age, did it? It just said age is more than 20.2. Well, is everybody's age more than 20.2? No. So we're talking about an average. Okay, so we're talking about a mean, and nowhere is sigma given, so sigma is not known. So if I come over here, claim about a population mean, sigma is not known, that's this first blank. And number off of the claim. What this is a number off of H0 or H1 or the claim, which is 20.2. So 20.2. Now alpha is 0.05. Population standard. Oh, wait a minute. I'm in the wrong one. I said sigma is not known, didn't I? So that should be over here. So that's 20.2. This is 0.05. Sample mean. That's 20.3. Sample standard deviation is 5.1. In. We had 25. Now notice it gives us the test statistic. And in some of the problems, the assignments will ask you for the test statistic. That's just whatever this value is. Down here is our p-value. And it's based upon whether we got greater than, less than, or not equal to on H1. In this problem, we have a greater than there. So if I go down, greater than, tells us is 0.4610. Usually those are rounded to 4 decimal places. And that's how you get your p-value. Then down here, it says that p-value is less than alpha. Alpha is 5%, this is 46.1%. It's not less than. P-value is actually greater than alpha. So if p-value is greater than alpha, this says we accept H0. Now you think of H0 and H1s are opposites each other. So if I accept H0, that means I reject H1. And this says determine the claim based on step 3. Well, step 3 we said which one does it match. And if I follow my line back, we said it matched H1. H1 we said we rejected. So if I follow this back, whatever we say about H1 is what we're going to say about our claim. So we're going to reject our claim. Now notice our claim was that the age is more than 20.2 and is obviously more than 20.2, but it was not significantly more than 20.2. Again, that's the whole idea behind this. Now, if you're wondering, well, what's your answer? Is that just the reject claim? Actually, your answer is the entire item here. So you may see a problem to ask you for this entire piece here. It's a proof, basically. Okay, so let's say the proportion, the percent of people in whatever believe that liked Breaking Bad is at most 21%. Okay, so that's a setup. I go and I talk to 500 people, so N is 500. And I find that 80 of them liked Breaking Bad. And I want to perform this claim based upon alpha being 10%. Okay, so step 1, write down a shortened version of the claim. Well, percent, which is also proportion, at most. At most. Think what symbol that means. I'm going to give you at most $20. That means I could give you $20 or less. So this is a less than or equal to symbol. So less than or equal to 21%. Usually you want this in decimal form, so 0.21. Step 2. Come up with a null and alternate hypothesis. H0 always has equals part on it. Well, if I think of the opposite of less than or equal to, opposite of less than or equal to is a greater than. So that means I'm going to have P is greater than 0.21 here. And remember, the only symbol we can put on H0 is an equals. Step 3. See which one it matches. Well, it has the equals part on here, and here's the equals part, so this matches H0. Now I need to find my p-value. Now this is little p, where this is uppercase P here, so don't confuse the two. This is our p-value. So I go over to my spreadsheet, and I'm doing a claim about a population proportion, so I come here. Number off the claim, 0.21. Alpha was 10%. X is 80. N is 500. We come up with our test statistic, which is right here. And what do we have here? We have a greater than again. If I go down to the greater than, it gives me this for my p-value. 0.9970. Now as I look at this, I can see that my p-value is greater than alpha. That's 99.7%, and this is 10%. That's the same as this right here, so that means we're going to accept H naught. Now, why do I know it's accept? I didn't say that. If p-value is greater than alpha, you accept H naught. That means if we accept H naught, that means we reject H1 because these are opposites to each other. And we have to see what our claim matched. Our claim matched H naught. See how the line we drew right here? So whatever we say about H naught is what we say about our claim. We accepted H naught, which means we'll accept our claim. So we accept that the percentage of people that like Breaking Bad is at most 21%. Excuse me. Okay, now let's talk about accept and reject. Reject. Actually, let me talk about accept. I had 2 students one semester that cheated on about every test. I knew they cheated. I never could catch them. I'd look over and I couldn't see how they were cheating and so forth. And I didn't make too much of an effort to really monitor them, like look at them the entire time. They both were failing. They both had like 20%. I'm not sure why they were cheating off each other. They would miss the exact same 35 items on a test, for example. Almost looked like one test had been photocopied. Very strange. They're pretty good cheating, you know. I'm not sure if they could look down and their eyes would go over to the other person's and I couldn't see it with their head pointing down like that. Do I know they cheated? No. I tried many times to catch them, never could. But I never did catch them. So I don't accept their innocence. Accepting their innocence is pretty strong. Assume I can spell innocent. Innocent. Try that again. I don't accept that they're innocent. What I do instead of accepting it is I do not reject their innocence. Now this is the wording you'll see in a lot of books. It's a little bit more accurate. Accept is a strong word. It means 100% I believe that they didn't cheat. This just merely says, okay, I don't reject their innocence. You know, maybe there's a slight chance. They study together. The odds that they make the exact same 35 mistakes on a test seems impossible statistics-wise, probability-wise, but I do not reject it. Now, I find students struggle with this wording, do not reject. So I stick with accept and reject, even though that's not technically correct. You think about a woman gets married. It's kind of the same idea as what we just looked at here. She goes on her honeymoon. Her husband flies off the side of a mountain. He's wealthy. She collects the insurance. 6 months later, she gets married again. And in the process there, her husband goes down to the local convenience store, and his brakes fail. He dies. She collects the insurance. Third time, she gets married again 6 months later. And while eating, her husband chokes to death. She collects the insurance. These are all investigated. There's nothing found to indicate she's tampered with brakes, that she's done anything to cause these deaths. So they can find no evidence she's done anything. But what is she doing? Well, she's killing her husbands. We don't accept that she's innocent. That's a pretty strong word. I mean, the evidence implies that she's doing it, but we do not reject her innocence. So that's the wording we use. Anyway, I want to talk about the accept and reject. Usually in a lot of books you don't see the word accept. They stick with do not reject for that reason. Now let me talk about a flowchart on this. So let me clear this off. Going to have a claim. And it'll be about a mean where sigma's known. Or it'll be about a mean where sigma is not known. And then the other is proportion. Now what this will tie to directly, and I'll put this spreadsheet out on the website, but it'll tie to this. Claim by the mean sigma's known, claim by the mean sigma's unknown, and claim by the population proportion. So depending upon which one it is, you use the appropriate one in order to do these tests. Now let me see if I can bring up the book. Okay. Now hopefully there's a additional information at the end. See, practice, online chapter. Let's come down to here. Now let's see if there's some problems at the very end. Oh, I guess there's right here. Let me go to the previous page. Just so you can see an example being read. Well, let's go back to here. This is just Arth1, doesn't it? As I'm sitting here reading this problem, meteorology storms. It says, Storms Weatherwise, a magazine published by American Meteorological Society. One issue gives a rating system used to classify nor'easter storms. The hit, okay, has the mean is equal to this. Suppose a nor'easter is progressing. Peak waves are usually measured from land. Suppose they're reading 36 waves. That would be our N. Showed an average wave height of X bar equals 17.3. That's obviously 17.3. Previous studies of severe storms indicate that sigma is equal to 3.5. Does this information suggest that the storm is perhaps temporarily increasing above the severe rating? Above. What does that mean? That means greater than. So that means greater than. And the severe rating usually, if it doesn't give you the number there, it gives it to you up above. So greater than 16.4. That'd be our claim. Alpha is equal to 0.01. You see how they say what's the level of significance? That's 0.01. Remember how I said greater than 16.4? And then the equals always goes on there. Okay, now on my my flowchart here, I got claim, mean, and sigma's known. So we're sitting right here. So for our spreadsheet, sigma known is this first blank right here. Okay, so number of off of our claim, 16.4. Alpha, 0.01. Population standard deviation, 3.5. Sample mean, 17.3. N. Reading of 36 waves, so N is 36. Okay, and this talks about sampling distribution, but oops, I clicked the wrong one. I have to click that one. It says compute the value of the sample test statistic. And you see I got 1.542857. It says approximately 1.54. Then it says find the p-value. Since we're dealing with a greater than on H1, I come down to the greater than, and that tells me my p-value is that. I may have a problem with my greater than. Okay, that one. My eyes are getting off. 0.068. 0.061. Notice it does not match exactly. Don't stress about that. You'll find is that the book will perhaps round these, and when you round these, then you'll come up with slightly different p-values. So they should be fairly close. 0.061 and 0.068, not too much of a difference. So if you're looking at these problems in the book and you're using my spreadsheet and you're thinking, boy, these aren't matching exactly, no, they will not be exact. It has to do with rounding issues and so forth. Okay, so then that gives you your p-value, and from there you compare your p-value to alpha. Alpha is 1%. So here my p-value is greater than alpha. Now notice the wording they use here. Fail to reject. I already talked about that. I said that's the except terminology that I use. So it says except H0. And they're telling you the reason why and so forth here. But that's how you would use my my spreadsheet here. Now this is specifically for one population and so forth. When you read the two populations, there's no assignments on those, but the same principle applies there, where you can use technology to get your p-value and then do the comparison. Okay, now I'm going to go ahead and stop the video. That's really all I had to say about confidence intervals and claims, and I'll answer any questions you have after I stop it.